In this lesson, we're going to learn how to do function operations. We can create new functions by adding, subtracting, multiplying, and dividing existing functions. So let's look at some new notation. F of x plus g of x can also be written like this over here, where it's f plus g of x. They mean the same things. All you have to do is add them. Similarly, f of x minus g of x is written in this format, f minus g of x. And it's telling you to subtract your two functions, but pay particular attention to the order. So let's create some new functions by adding f and g of x. So as I look here, I'm given 2x to the 1/2 power. Remember that this would be equivalent to 2 times the square root of x. And g of x would be equivalent to -6 times the square root of x. So if you think about what breaks a domain here, when we think of the domain, I recognize that I can't have a negative radicand. So for both of these, my domain is going to be from 0 to infinity. All right, I just like to always think about my domain before I get started. So this means to add my two functions. So I'm going to put 2x to the 1/2 plus -6x to the 1/2, or just minus would be equivalent, and that's equivalent to -4x to the 1/2. Now, to subtract them, okay, just pay attention to your order. 2x to the 1/2 minus -6 to the 1x to the 1/2 is actually going to make it be plus 6x to the 1/2. So my new function is equivalent to 8x to the 1/2. I'm just combining my like terms. And if I read the next two questions on my note guide here, I'm telling you to find the domain of f of x, which I already talked about. And I was a step ahead of myself. I just need to write it down here from 0 to infinity. And the domain would be the same for g of x. This should be called g of x here, from 0 to infinity as well. So when I add these two, it's really the intersection of my two sets. Well, they have the exact same domain, so it's going to be from 0 to infinity. And this one will also be 0 to infinity because it is the intersection of the two sets. To make sure you understand what I mean, so if one function had a domain of, let's say, 2 to infinity, and the other function, g of x, had the domain from 0 to infinity, you're thinking in your head, well, where do they overlap, like on a number line? Well, they would both include from 2 to infinity. So if I wanted the domain for f plus g of x, it would be the intersection of the two, so 2 to infinity. We can also multiply and divide two functions. So this notation here means to multiply f times g of x. I just want to caution you that sometimes you're going to see a very similar notation where the symbol in the middle is an open circle. Be careful, these are two completely different operations. We'll look at this one over here in the future, but just be aware, okay? So we're going to multiply our two functions. So f times g of x would be equal to, take 3x times x to the 1/4, and now let's just use our exponent rules. So it'd be 3, keep my base, and I'm going to add my exponent. This would be 1, and 1 plus 1/4 would be 1 1/4, or 5/4. I also need to state the domain, so I'm going to look back at the original domain. So for f of x, it was linear, so that's -infinity to +infinity. No restrictions. Here I have an even root, so I know it needs to be positive, so it'd be 0 to infinity. Now, for the domain of my new function, it's going to be the intersection of these two things. So what they have in common would be from 0 to infinity. And when I say what they have in common, if you're struggling to understand that, you picture that you have a number line. The f of x, I'll highlight in yellow, would be everything on the number line. And g of x would be from 0 to the right. So where they overlap from 0 to positive infinity, and 0 is included, so be closed circle. All right, 8f divided by g of x would be 3x divided by x to the 1/4. So as I simplify this, 3 divided by 1 is 3, and then keep my base, subtract my top exponent minus my bottom would be 3x to the 3/4. Now division is the one operation that has a little extra something you need to think about when it comes to the domain. So the intersection of the two would still be 0 to infinity, but you need to consider the denominator. So before we simplified, right here I had x divided by 1/4, and we've got to think we can't divide by 0. So 0 can anything that would cause the denominator to be 0 also has to be excluded. So my domain wouldn't be 0 to infinity like it was before. It can't include 0, so it would be with a parentheses 0 to infinity. The last type is a slightly different notation. It says find f of g of 5. And there's really two ways you can do this. So the first way of doing this is to find f of 5 and multiply that by g of 5. Like plug 5 into the original functions. So f of 5 would be equal to 3 times 5, which would be 15. And g of 5 would be 5 to the 1/4 power, if I just plug in. And then if I multiply these together, I would get 15 times 5 to the 1/4. And I wouldn't be able to combine those any further. There is, of course, another way to do this, and it would be to plug in 5 into the composition, or excuse me, into the multiplication of the two functions. So we did that just a second ago on a previous slide. We multiplied the two together, and we got that it was 3x to the 5/4. So you could then plug 5 in, which would be 3 times 5 to the 5/4. Take a little bit more work to get us to the answer in this scenario. So just to remind you, 3 times 5 to the 5/4, this would be equivalent to 3 times the 4th root of 5 to the 5th power, which is 3,125, but then I'd have to break that down, so I need something that is to the 4th power. Well, I think 5 to the 4th is 625, yep. So this would be 3 times the 4th root of 625 times, I could do the 4th root of what's left over, 3,125 divided by 625 is 5. And then this portion right here, I can take the 4th root of 625, it is just 5. So I would have 3 times 5, which is 15, times the 4th root of 5. So these two things are equivalent. I think the first scenario in this particular case is a little bit easier to think through. Now let's do g divided by f of 3. So again, two ways of doing this. We can find g of 3 and then divide that by f of 3. So g of 3, if I plug that in, would be 3 to the 1/4 divided by f of 3 would be 3 times 3 would be 9. And if I think this through, though, if I want to use some exponent rules, I think I'm going to actually change this back to 3 squared rather than 9. So now I have like bases. I could keep the base and take the top exponent minus the bottom exponent. So 1/4 minus 2 would be to the negative 7/4. And I look at what I have here, and I have a negative exponent, so that's equivalent to 1 over 3 to the 7/4, or the 4th root of 3 to the 7th. And I think, well, gosh, I can't have a radical in the denominator of a fraction. It's not rationalized. So if I rationalize the denominator by the 4th root of, not 4, but 3, top and bottom by both, that would give me on the bottom the 4th root of 3 to the 8th, which would be 3 squared, or 9. So I would have 9 on the bottom, and on the top I have the 4th root of 3, which ironically puts us exactly back where we started with. So I probably could have just left it like this, but I didn't recognize that at first, that was okay. And this is the beauty of math. I tried to simplify it, and when I did, I created this issue with the radical in the denominator. Switching it back, rationalizing the denominator gave me what I started with. Okay, of course I did say that there was a second way to do this problem. So let's examine the second way, which would be to first do g of x divided by f of x. So if I do g of x divided by f of x and then plug 3 into that result. So g of x was x to the 1/4 divided by 3x. So again, here I would probably try to clean this up a little bit. I would get this right here, and I recognize that I've got like bases, and I think the same thing is going to happen to me before as what happened before. If I keep the base up top and do the top minus the bottom, exponent 1/4 minus 1 is negative 3/4 over 3. And then what happens is becomes 1 over 3x to the positive 3/4. And now what happens is I'd need to rationalize my denominator by multiplying by x to the 1/4, top and bottom, and that would produce 1 times x to the 1/4 is x to the 1/4 over 3/4 plus 1/4 is 1, so just 3x here, and check it out, look, it's exactly the same as my very first step. So trying to simplify it isn't helping me at all. So beginning here and then plugging in 3 gives me 3 to the 1/4 over 3 times 3 is 9, and I'm not going to one more time try to simplify that, only to go right back to where we started. Final one in your notes, f divided by g of negative 2. I'm going to plug negative 2 into each function. So f of negative 2 is negative 6. G of negative 2 would be the 4th root of negative 2. And this is imaginary. So when we encounter one like this, we're going to state that there is no solution in our real number system. We cannot evaluate this. Which is a breath of fresh air, right?